All right, so in 9.3, we're looking at circles, which I believe in geometry, you guys have been introduced to this stuff before. So I'm hoping that the equations that we're going to be using will look at least slightly familiar to you. So the official definition of a circle, this is what you'll see in the book. I'm not going to make you memorize the definition, but this is exactly what a circle is defined to be. It is the set of all points in a plane plane meaning like the two-dimensional space, like a coordinate system, like the XY plane, that are equidistant from a given center. Okay, the set of all points in a plane that are equidistant from a given center. Okay, so the center that we're going to talk about, that is the point H comma K. So we just use HK, it's what you'll see in the book, it's what I'll be using, it represents the center, and so it could be centered anywhere on the entire XY coordinate system. And then that distance that we're talking about is the radius. So the distance between the circle and the center of the circle, they're all equidistant, and so that's R, the radius. All right, so let's sketch a little something here. So if you pick, anything. So let's throw a center over here. So say that's a center. So the circle is the set of all points that are equidistant from this point right here. So if you picture, I don't know if you guys ever used compasses, not like north-south compasses, but like drawing a circle. You would literally set a distance like this and then spin the compass around, and so it would have a set circle. I wish I currently had a compass because drawing circles is one of the worst things that I do, so get super excited for this. So if I had my compass set, you would draw around that center. It would look something like that. Ooh, maybe I should say that every time. That was pretty good. So all of these points on this circle are the exact same distance back to this center. So like this point to the center is one distance, same distance here, if of course it was a flawless circle, which I'm assuming not you or I will actually draw. So if we say like this, pick some random point on the circle and let's call it XY, then this distance right here is the radius. Okay, so that is our distance R. And so there's a reason that we do circles after we do midpoint and the distance theorem and everything like that, and that's because this circle formula is very closely tied to the distance formula. So let me write that down for you just to remind you. Distance formula looks like this: big square root x2 minus x1 squared plus y2 minus y1 squared. All right, and so what we do is we're actually going to use these things over here. And so what we know is that instead of D, we're actually using R to represent the distance. So this becomes R equals, same thing though, big square root. And then we're going, so like here's our x1, y1, here's our x2, y2. So we do x minus h squared, and then plus, now the change in y would be y minus k squared. Now remember, since we're squaring, it doesn't matter if you do x minus h or if you do h minus x. In the formula, we usually put the variable first, so that's why you'll see it like this. And then the very last thing from here is to get all of this stuff. You don't want a big square root in like a formula that you're going to use all the time. So what we're technically doing is we're taking this side and squaring it to get rid of that big square root. So you would also square the other side. And then you end up with this formula right here. Okay, so you can see like what I have written here is very similar to what I've written here. I just squared both sides of the equation. And so it looks like that. And so that, I'm hoping that's familiar to you. You probably saw that in geometry. And then we have, this is the simpler version. We're going to write down exactly what this is. So I'm actually going to start over here. The center is h comma k, just like we talked about up above. And now notice, this is subtraction, so it's actually going to be the opposite of what you see there, but we'll talk about that in just a moment when we start looking at specific examples. And then the radius is r. So that's all the stuff that we had written up here. We know hk is our center. We know r is our radius. That's what led us over here, which in turn led us right here. So we know this is the center and this is the radius. If we move over here to a simpler equation, This, we don't have like an x minus h or an x plus anything. Same thing with y. It's just plain, it's by itself. So what that actually means is that this is the simplest form where we're just centered right at the origin. So you could think of that as being like an x minus 0 if you wanted to, but that simplifies, of course, down just to an x. So if it's centered right at the origin, the equation is going to look like this. The radius is still r, okay? So we're going to look at a specific example. This is kind of a story problem type of example. So we have a certain Wi-Fi phone has a range of 30 miles in any direction. That value right there is just like the radius. Okay, so that's r. That's what we're going to use in our formula. And then it says if the phone is 4 miles south and 3 miles west of headquarters, so that's like the center. All right, so we are moving that to be our center, and then it can go 30 miles in any direction. So they're considering headquarters to be like the origin, and so then this would help us to figure out what our center is. So our center, we always use C for the center. Let's start with X. X goes left and right, and so that would be like east and west if we're looking at directions. 3 miles west would be to the left. Picture like north, south, west, east. If we're going west, that would be to the left, which would be negative. So we would have a value of -3 here. And then south is down. And so in terms of y, that would be a negative y value. So the center is at -3, -4, if you picture that as being on like a coordinate grid. And then the r, the radius, is 30. And it kind of gives you a little clue in this wording. This is like in any direction, kind of sets it up as being the radius. So here's the center, here's the radius. I'm going to first write down the generic formula that we have right here. So we start with this super generic formula for a circle, and then we're going to plug everything in. Okay, so if we're looking right here, this is your h, this is your k, this is your r, which I already have written right there. So we're going to plug those 3 values right into this formula and simplify it up. So we have x minus, and then h is a -3. Y minus, and k is a -4, and the radius is 30, and we square it according to this formula right here. So now just simplify it up. You don't ever want to write minus and negative. That's kind of tacky. So change that to plus squared, and then y plus 4 squared. And 30 squared, 30 times 30 is 900, and that is the equation that they're looking for. All right, so this is write an equation to represent the area. So any value of x and y would give you a nice little outline of the area where the phone can operate. Okay, so that's your first example. So basically, based on what we just wrote here, you can come up with this equation if you know where the center is and if you know a point on the circle. So here we just did it with the center and the radius. You can also find the equation if you know the center and then a different point, because you can use that different point just like this to find the radius. Okay, so that's the next set of examples that we're going to be looking at. If you flip the page. So here, if you look, you've got a point on the circle and then you've got the center. So here the center is 0, 0. Here the center moves to -1, 4. So if you look closely, I know everything's kind of jumbled in with the grid lines there, but you can see this is the center, and then this is a different point. Here the center is at 0, 0, and then this is a different point. So one more time, I'm going to write the generic equation just so we have it in front of you. And remember, you guys are going to have a note card, so these are all formulas that you'll be able to access. So just to keep this in front of us. So this 1, 5 is basically like our x, y. It's like the secondary point that's not the center. So for x, we're going to plug in 1 minus, and then the x value of the center is 0 squared, plus the y coordinate of the other point is 5 minus, and k, the y coordinate of the center is 0 squared equals, and then we don't know the radius. That's what we're trying to find. So we just leave that for now. And then simplify everything up. So 1 minus 0 is 1, 1 squared is 1, plus 5 minus 0 is 5, 5 squared is 25, and that equals r squared. So 1 plus 25, of course, is 26, and that's r squared. Now the good thing about this, you don't need to find the radius because the formula actually wants r squared. So it would be pointless to square root it just to square it again. So we're just going to leave this right here. So now let's plug what we know into this formula. So x minus the x coordinate of the center is 0 squared, plus y minus the y coordinate is also 0, and then the radius squared is 26. So you can write it like this. This is a completely acceptable answer. You can also kind of simplify it down and write it like the form that we had on the previous page. So either way, whatever makes you happy, totally fine with me. Okay, let's do one more of these. So same formula that we've got up here. I'm going to make sure it stays on the screen so we can access it. Here's a separate problem. So x coordinate is this point right here, -4, minus the x coordinate of the center is -1 squared, plus the y coordinate of the secondary point is 6 minus the y coordinate of the center is 4 squared, and then just like part A, we don't know the radius, that's what we're trying to find. So -4, change this to plus a positive, just to make things easier on you. -4 plus 1 is -3, and then if we square it, we get 9. 6 minus 4 is 2, and if we square that, we get 4. Okay, 9 plus 4 is 13, so that's what's going to go in for r squared right here in our formula. So let's fill in. So x minus, the x coordinate of the center is -1, so instead of minus negative, I'm going to write plus 1. Then y minus, now we need the y coordinate of the center, which is 4, equals, and then whatever r squared is, and we know from right here that r squared is 13. And that's it. All we're looking for is the equation, and we've got the equation. So the other thing that you can do with this, so we're kind of taking it step by step. In example 1, I directly handed you the radius and the center. In example 2, I handed you the center, but a different point that helped you find the radius. Now here, we're going a little bit different. Now we have endpoints of a diameter. Okay, so I want you guys to get kind of a visual on that. And I'm actually gonna, why not? I'll plot something else right here just so you can see it. So 3, -3, so just very, very quickly plot a point there, and then 1, 5. So right there. So this is the diameter. Okay, so that means the rest of the circle kind of goes around like this. Oh my goodness, I told you guys. Okay, so let's pretend that that made a circle. So here at endpoints of a diameter. So remember, diameter goes all the way across, whereas a radius only goes halfway across. So what we're going to do is we're going to find the center. And so that is this point right here. That is what we're trying to find. And so if you think back to what we did a couple of days ago, that requires us to use the midpoint formula. So if we find the point that's halfway in between this point and this point, it'll be the midpoint of the diameter, which ends up being the center of the entire circle. Okay, so we're bringing it back to 9, 1 again. So again, if we want to go halfway in between these 2 points, that gives us the midpoint of the diameter, and the midpoint of the diameter ends up being the center of the circle. Okay, so let's do a midpoint formula here. So halfway between here, so remember the way the midpoint formula works is you add the two x values together and then divide by 2. That goes halfway in between them. And then same thing for y. You add the two y values together and then divide by 2. So the midpoint is 3 plus 1 is 4. 4 divided by 2 is 2. And -3 plus 5 is 2. 2 divided by 2 is 1. So we actually plotted that. I plotted that fairly accurately there. It looks like 2, 1 would be the center. And so you know, based on your formula, that this is H and this is K. Okay, so we've got the center. So if we look back at this formula right here, we've got H, we've got K. What we don't have yet is R. And the way we find that is by, the same way that we found the R here. We plug in, now we have 2 points you could use. You could use the point 1, 5, or you could use the point 3, -3. It does not matter at all. Maybe you want to avoid negatives, so you want to use that one. I don't care. Whatever you want. So we've got x, which is 1, minus h, which is 2, squared, plus y, which is 5, minus k, which is 1, squared equals the radius squared. And just like we did in example 2, we're just going to clean this up. So 1 minus 2 is -1. Squared is 1, plus 5 minus 1 is 4, squared is 16, and that's the radius squared, so that's 17. Okay, so into my formula, I now know the radius squared, and I know the h and k. So let's see if oh, perfect. Okay, so I'm going to sneak this formula right on the screen here. So x minus h becomes x minus, and then the h is 2, squared plus, and then y minus k. We have y minus, and I labeled here that k was 1, squared equals, there we go, r squared, and I know that r squared is 17. So I plug that in, and that is the equation of this circle. Okay, so that's the equation stuff. So basically 3 different ways that we could do it. You could either have the radius in the center, which is kind of the easiest of all. You just plug it right into the formula. Example 2, we saw a center and a different point. And then here, the third way is kind of like secondary information that can indirectly lead you either to the radius or to the center or both. Okay, so that's probably the most complicated type. Circles. Let's graph circles. Example 4 will be pretty straightforward, but now we're going kind of backward. We have the equation in front of us, and we're going to work our way back to the graph. So here, find the center. So the center, remember, if this is just an x squared, the x coordinate is 0, and if this is just a y squared, the y coordinate is 0. So that's our center. We put a C right in front of it to mark the point. And then the radius, remember in our formula, this is an r squared. So that means r squared is 81. Okay, so if r squared is 81, that means that r, if you take the square root of both sides, r would be 9. It's not plus or minus 9, it's just 9, because a radius is like a distance, and distances are always positive. Okay, so let's get a quick sketch. So start with your center. So the center, now it isn't a point on the circle, but you do want to see where it is. So I'm just going to mark it with green. Actually, you really can't tell that's green. So let's scale. Scale by 3. So 3, 6, 9. Same thing here. Make that 3, 6, 9. Negative 3, negative 6, negative 9. Negative 3, negative 6, negative 9. Now this is where my talent fails me here. Oh no, it's bad already. Oh, God. Oh, just pretend, guys. If you use graph paper, it actually does get a lot easier because it can, like, these probably aren't evenly spaced. But let's just pretend now. Believe me, in no way will I judge you or mark you wrong if your circles aren't pretty, because I am the last one to talk. This is as talented as I get. All right, so as long as you've got the center and the radius, you are more than fine here. One more example. Okay, so now this one, example 5, is what you guys will probably find the trickiest with circles. We'll do it again with ellipses. We'll do it again with hyperbolas, so hopefully you'll get used to it. What we're going to be doing with this one is actually kind of a weird version of completing the square. Okay, so this is called standard form for a conic section, so it could represent anything. Circle, ellipse, hyperbola, even though we haven't gotten there yet. What we're going to do is we're going to complete the square, so we're going to gather up all the x stuff together, kind of group that together. So I have the x squared and the 4x. I'm going to do the same with y. I'm going to group together my y stuff. So I have a y squared and a negative 10y. And then what I'm going to do is any constants that I have, I'm going to boot them off to the right-hand side. Okay, so I had a minus 7, so I just added 7 to both sides. It looks like this. So I've got these groups, and what we're going to do is we're going to complete the square within that little group. So take a look at this one right here. I have x squared plus 4x, and then the way we're going to complete the square, remember you take this middle number, this 4, and you cut it in half and square it. I'm hoping that sounds familiar. So we take 4, we cut it in half and square it. Half of 4 is 2, and 2 squared is 4. Okay, so it's like a little mini completing the square. Okay, so bear with me for a second. Hopefully it'll make sense once we're done. Next grouping is my y grouping. So I'm going to do the exact same thing here. I'm going to complete the square on my y terms. So I start with this middle term, whatever's attached to the x or the y. My middle term is negative 10, just like before. I'm going to cut it in half and square it. So when I cut this in half, I get negative 5. And when I square negative 5, I get 25. Okay, so now I've just completed the square with my y stuff right here. Now, remember this 7 floating on the other side. I did totally illegal things over here. I just added a 4 where there didn't used to be one, and same thing with the 25. In order to keep the balance, if I'm going to add 4 over here, I've got to add 4 over here. And if I'm going to add 25 right here, I've got to add 25 right here. So what I'm doing is I'm taking this very weird form, and I'm transforming it into the form that we learned on the previous page. Okay, so this piece right here, what I can do is I can factor it down using my little completing the square tricks. What multiplies to 4 and adds to 4? Well, that would be 2 and 2. So this becomes an x plus 2 squared plus what multiplies to 25 and adds to negative 10? That would be negative 5 and negative 5. So this becomes y minus 5 squared. And then 7 plus 4, that's 11, plus 25 is 36. Okay, so that is my standard form of a circle. That's what I was working with on the previous page. Okay, so now what I want to find is the center, and the center is -2, +5. Remember, it's the opposite of what you see in here. So the opposite of +2 gives me -2 for my x-coordinate. Opposite of -5 gives me +5. And then for the radius, remember this is r squared. So if r squared is 36, the square root of that is 6. So I know it doesn't ask for it, but I'm going to show you guys what the sketch of this would look like. So start at my center, so -2 and then +5. So kind of just mark that on there. It's not necessarily a point on the circle, but you do want to see it on your graph. And then a radius of 6, we haven't graphed something like this before. What you do is you start at that center and move up, down, left, and right 6 units. Okay, so from here I'm going to go over 1, 2, 3, 4, 5, 6. So over 6 units, I'll leave a point right there. From here I'm going to go down 6, so down 1, 2, 3, 4, 5, 6, leave a point right there. I'm going to go 6 units to the left, 1, 2, 3, 4, 5, 6. So 6 units this way, leave a point right there. And then again, from the center, I'm going to go 6 units up. So sorry, it's going to run into my problem a little bit. 3, 4, 5, 6. So 6 units up, right there. Okay, so now you just sketch in your circle based on those points. Oh God, it actually wasn't that bad. Okay, and that's what it would look like. So your center kind of shifts you around, and then the radius you use to count right, left, up, and down. All right, that's it for circles.